Hello friends, today this intelligent dog will explain important engineering concept which is Thiessen Polygon. So keep watching till the end. Imagine you have a dog at your home and you are going to beach with this dog. Say this is the beach with sand in it and you are having a sun bath. It's a very hot day in the summer and what you are searching is for cold drinks or some ice creams, and you just find different stalls of ice cream sellers there in the beach. So these are the locations of the ice cream stalls spreaded over the beach. Say you and your dog are here in this position. Suppose you wanted to buy an ice cream. So which will be the best option for you to go to buy the ice cream? You will certainly choose the ice cream stall which is nearest to you. You don't have a mathematical tape to measure the distance between these three stalls, so you are just gonna estimate the distance between them. And if you have a good intuition in estimation, you can choose between these three ice cream stalls. But since you have got a very intelligent dog, it will say the answer for you. But how does it know that which will be the nearest stall for you? Let's see how. So what is the important property that a dog possesses but the human beings don't? Yes, it's the property of smelling. The smelling power of dogs is quite powerful than humans. Let's assume each of these ice cream stalls will spread a tasty smell of ice cream, and also assume that in ideal cases the strength of smell of all these stalls is the same. So let's see how the smell is spreaded. Assume that the smell for each of these ice cream stalls is represented by a different color. So since the smell is spreading outwards, it is denoted by a circle with a color. And since the strength of smell is all same for all these stalls, the area of circle will increase with a constant increase in its radius. For our consideration, let's see these two ice cream stalls and how the smells are spreading. So let's see this again. At first we were in this condition. After the smell spreads, it will be like this, and there comes a point when the smell of this ice cream stall reaches the smell spreading from this ice cream at somewhere here. And afterwards what happens is the smell spreads outwards. The smell in this area is dominated by this ice cream stall, so further spreading is avoided. So the blue smell cannot spread to this area and this smell cannot spread over that area. So it will leave a borderline which is shown by this line, and it will go on spreading. The same is the case with all the two ice cream stalls with respect to each other. For example, for these two ice cream stalls, it will reach to a certain point where the smell spreading from this ice cream stall and the smell spreading from this ice cream stall will meet at a certain point, and it will spread, making a boundary line between them. So when the smell is totally spreaded, it will reach to a figure like this. Now the question comes, how does the dog know? So let's see the smell coming from this ice cream is spreaded over this red area, or in other words, the dominant smell in this red area is the smell coming from this ice cream stall. So since the dog is sitting in this location, it should know that it is falling in this polygon or in this red area. So the dog will insist you to buy the ice cream from this stall. So these polygons represented here by different colors are called as the Thiessen polygons or Voronoi polygons in mathematics. So the concept of Thiessen polygon is that if there are different points in a geometry, every point has got its coverage area, such that within this coverage area, this point is the point which is the nearest from any point on this polygon. So if instead of being here, if you were in this position, you will fall in this Thiessen polygon. So the nearest ice cream stall will be this ice cream stall. Actually, this example is shown to you just as an illustration of what the Thiessen polygon mean. In practical, the smell cannot be spreaded in such a way, and there comes the theory of diffusion and different gas laws that won't give you the same result as I have shown here. But anyway, congrats to this dog for answering the engineering question of Thiessen polygons. Now we have already known the concept of Thiessen polygon. Let's know how to draw the Thiessen polygons. As we have already seen the simulation for this, let's observe the simulation in details. Let's retrace the video. Consider the simulation for these two ice cream stalls. Let's draw a line between this and this ice cream stall. So the distance from this point to this point is the radius of the circle, and the distance from this point to this point is also the radius of the circle. Since the smell from these two stalls are spreading at the same strength, so the radius of this circle will be equal to the radius of this circle. So we can say that these points bisects this line at the center. And if you continue the simulation, so from the same point a line will be created such that it creates a border between these two circles, and it's nothing but a perpendicular line drawn to this line. So this line is commonly called the perpendicular bisector, joining the line between these 2 points. So let's look for other stalls also. Let's see these 2 stalls. For here also, the circles will meet at this point. So this will be the perpendicular bisector joining these 2 points. So as you can clearly see, the Thiessen polygon over here can be drawn from the combination of these perpendicular bisectors. So in college we have been learning that we can draw the Thiessen polygon by joining the perpendicular bisectors of the line joining the 2 corresponding points. So these are the concepts of Thiessen polygons. But why do we use Thiessen polygons in engineering? Being a civil engineering student, I will explain the application of Thiessen polygons in engineering, especially in water resource engineering. But in practice, Thiessen polygons have a lot of applications in different areas. As you have seen in the previous video, the locations of these ice cream stalls are nothing but these are the rain gauge stations, and this overall area is nothing but a simple catchment, and each rain gauge station has its coverage area for the rainfall. Or in other words, if we are going to find the average precipitation of this area, we need to take the weighted averages of all these areas. So these Thiessen polygons are used to find the average precipitation, which we commonly call the weighted precipitation of this area, considering that this whole is one catchment area, and these Thiessen polygons are the coverage of these corresponding rain gauge stations. So that's all about the Thiessen polygon, and we would like to thank the dog for explaining the Thiessen polygons and giving a new concept and a new approach of understanding the Thiessen polygon. Thanks for watching.